Okay, I'm just going to run right down a list and show you what Rod sent me everything. He sent me a lot of anomalies. This is just a normal light wave. Now, you look at that and you see a light wave. It's not a light wave. The particle is literally that. There's two explosive balls and there's two non-explosive balls. Boom, 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 boom. They're shooting out pulse after pulse. This is what's out here. The particle's way back here. And I will show you that because we put this through an accelerator, which is nothing more than a venturi. And let me set that up for you. Hold on. All right, don't forget, electron flood theory. Nothing more than electrons exist. A red laser, pulse, pulse, pulse. They are those balls of magnetism, just a particle in the center. And then they're going to suck this through the venturi. There's two metal pins. And this we're looking at the side of it like this. Here we're looking straight down from above. So these are those pins looking down from the top of it. Now, here's what this light did. Hold on. All right, just so you understand what you're seeing here. Don't forget, electron flood theory. Nothing exists except electrons, but they are positive and negative. The negative extremely explosive, the positive just walks away as a black ball when they do this acceleration. This is fully understood. I'm going to go through it or have gone through it. You've either seen it or you will. And these are the concussive explosive, and the black ball is the non-energetic part. Now, here's that light wave we saw before. Now it's being accelerated. And instead of that particle that existed way back here, it's being pulled out because it has to accelerate to get through the venturi. So now we're going to see it. It will start to show itself here, and it starts to glow white. And then when it hits here, it explodes. And the black parts walk away from the white parts. Let's look at that. All right, here's your venturi, right there. The light comes in. It has to force its way through there, just like a garden hose. At this point, though, the black particles want to get away from this explosive event. So the white particles push them away, but ever so gently, it appears. And then they somehow rejoin back to the white particles over here. That, to me, is a weak force and a strong force. And these create the showers, which I'm going to show you in a second, and they also created a particle that could be this lepton particle. I don't think so, but who knows? We want to look at it. Let's look at it. Okay, you remember the laser comes through here. Now, if we pointed this right at us so that these showers coming directly at us, that's it right there. There's the venturi right here. We're looking into it. And these particles are coming at us. And every one of these is, I believe, an electron. Is the electron neutrino. And they create the showers. Now, that one there is not like the rest. That one, I believe, is spinning backwards. And that one did not concuss the way these concussed. What this did, though, is it interacted with one of those and created a very strange particle that I'll show you right now, which is this one right here. Now, that, I believe, was that white particle. Now, it's not like all the rest of them. All the rest of them came through like this. And they're all coming this way because you can see the concussion is in the front. Now, this appeared to hit this disk, this field. What happened after that, I don't know. I can see this. Now, I don't know if that's got more of a mass. I don't know if it's spinning in the correct direction. It could be spinning reverse. I don't know what's going on. Did this come around and scrape against it and force it to spin? I don't know. I have no idea. But it appears that this has converted to this. It's not like this is merging with this. It appears that this is now becoming this. You see it? There's some kind of a... You can see... I don't know. That's what I'm taking away from it. Now, anytime you see a lot of glow, it means there's a lot of energy. Now, there's a lot of energy in a small particle. Now, there's enough energy here, but you got a big field that's moving. This, I don't know. I have no idea. At this point, it's all up in the air. But they're looking for a tau electron. Well, tell me what that is. If it's not a tau lepton, what is it? It's not. It's not the electron neutrino, which I say that's an electron neutrino, and it's not the black ball, which is I say is the tau is the muon neutrino. So this is the tau neutrino, as far as I'm concerned. I don't know. I'm just teasing. It could be anything, but it's something. And this shows that light spins. Let me see here. You see that? This is a single slit. Light is a spinning particle. It's a particle, and it comes through and it spins. Sometimes it spins off to that side. Sometimes it spins off to this side. But it's spinning all up and down here. It's not just one little spin going here. So they're coming through in all different ways. Rod's got them coming through the venturi, so that most of the impact is going to drift towards the center. But there'll be some that come out that way, and there'll be others that come over this way. But you can obviously see, and if you're a machinist, you can tell that is a screw drill bit. That's what's going on. It's spinning light particles. And that's what creates these interference patterns. And they're not really interference patterns. What they are is, as these particles come through the slit, these want to push each other away. You can see them. They're starting way in here. Get away from me. You get away from me. You get away from me. You get away from me. And they do that back and forth, and they set up these lines of push. Call them whatever you want, interference, but that's why they make those little bumps. This is a single slit, so it's not this going wave and this going wave and so forth. They are particles spinning. All right, before we get too deep, all this research is based on the principle that the nucleuses of all atoms consists of electrons. And an electron is not just a negative particle. An electron is a dipole, which means it has a positive and a negative. We would call the negative the strong force. That's what we've always called electricity, a negative flow. Now, the weak force is the positive. These atoms will form quantities of electrons that become stable at certain quantities because they're pushing and scrubbing at each other all the time, but at a certain frequency, they lock right in. And I can show this in the salt table experiments. Look it up yourself. Very simple to find. Salt frequency table experiments. Now, and then look up tractor beam magnets. It shows how the electrons are held at bay because they want to get into that positiveness, which will be in the center. Because these are negative, they want to be with positives, but the negatives will always surround the positives because the positives don't mind being together, the negatives don't want to be together, so they form a shell. More negatives want to come in to be with the positives. They are held at bay. Those are called the orbitals or the zones of electron interaction with the nucleus. Let's call it that. Now, when these things are moved out of here, normally two electrons will come together and form a photon of light, and that's what we feel as light, really. And it actually turns into heat. Now, at the heat stage, you can be just pushing electrons in. And if you just push them in slowly, you're just heating things up. If you push them in real fast, you're going to burn something. We're going to talk about all that. Now, the experiments you're going to see were done with a red laser light. Very, very simple pulsed red laser light. Bip, 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 bip. And then we will show the particles, which they are particles, accelerate. And then I'll show that they separate from their concussive portion, which is, as I show, the electron. You have a black and a white, and the white part will form extreme violent reactions, and the black balls will roll around, and then they will come back together. So if they're looking for neutrinos, and they think these, what they're calling sterile neutrinos or non-interacting neutrinos, these would be muon neutrinos. I can't see them staying away from all the other neutrinos forever. They say they go right through the Earth. I don't think so. I think they're going to come back to these white particles as soon as they can find one available. These are going to become available as they slow down. Let's start looking at these things. All right, stay with me. This is Roger. This is going to be very simple. It's about neutrinos, the smallest particles that exist, they say. And CERN does it by smashing neutrons together, nucleuses together, and exploding tons of particles. We can show these using light. Now, and I will show it to you exactly what they are. Now, it's called electron flood theory. This is my theory. I've been working with Rod Warren. He's been doing the light experiments. He originally discovered that if you put light through a venturi, it would accelerate, and you could actually separate the particles. It's just something I saw him showing pictures, and boom, I knew what he was doing. Then he graciously did a bunch of experiments to prove. Basically, I'm showing you he proved it. Now, an electron is this: a very weak portion and a very explosive portion. 1837 of these make a proton, 1838 make a neutron. But they are electrons. Now, they will come into a mass. The black balls don't care about, they don't have any energy to speak of. They never do anything other than be that black ball. This one will explode like a bomb when they impact. These just boom. They want to push each other apart. The black ones just get out of the way. Photons are two electrons together. In a photon configuration, there are at least two, there might be four. There might be a box that looks basically like this. But at any rate, photons don't have the same energy as electrons. Electrons want to be incorporated into something else to become more or less stable. And a photon, they become more or less stable. They will bang into you and create energy and electricity if they hit the right thing, and so forth. But they don't really, they're not like lightning or electricity where you have just raw electrons, even static. If you have enough electrons, it will force its way into matter and it will destroy the matter. Photons don't have that same, you can concentrate them and burn somebody, but that's a little different than electricity. Electricity is incorporating them in. If you can make it go in slowly, you're just warming everything up and the soup absorbs it, up to a point when the soup starts to boil. When the soup starts to boil, everything in it starts to get changed. All of the cabbage turns into mush and all of the potatoes turn into this and that. And literally the same thing happens as it's called combustion, it's called nuclear degradation. You're changing the molecules around. So they aren't what they were before because we have flooded them with electrons until they became destabilized and then restabilized. Okay, Roger once again. Done this so many times, I'm going to run through real quick. Pulse red laser, not accelerated. Red laser being accelerated into a venturi, a fully understood crushing device that atomizes gasoline in old carbureted cars. Well, this is actually atomizing or deatomizing the light particles and separating them. And before they concuss here, they demonstrate themselves as what they are, is a box of electrons. That's one electron here, and that's another electron here. Back to back, they form light and will not kill you. Once they separate, all the bets are off. If there's enough electrons being forced at enough potential, they will kill you because they will force their way into the matter that's in front of them. Now, we're going to go through this whole thing about how light accelerates, how light is a particle, how light has mass. These are what they call electron neutrinos. The black balls are going to roll away from these spinning disks. And I will show you all this in a second, but let's go see what they say about neutrinos, and then we're going to go into some extreme details, because it's getting deeper and deeper. And there's this guy, and I'll talk about him later. He's done like 7,000 papers. Every day I see at least a few papers. He's worse than I am. I'm pretty bad, but they're good papers. The guy's got some good stuff. He's keeping up on the latest stuff, and that's what you need, somebody like that. So, George Rana, I think is his name. We'll get into that deeper later, but let's see what the neutrino world says about their neutrinos, because I'm telling you right now, my neutrinos Let me show you my neutrinos, then let's see about their neutrinos. Okay, my friends, we are in for a treat because I'm telling you, I'm seeing this as a bowl of candy myself. And if you got kids or anybody that's a science wannabe or thinks they are a science person, tell them to get over here and watch this. And watch it with them because I'm just getting started. I have been, you know, I do light research. I've been doing it for years, and it's all about atomic theory. Now, as we keep getting deeper and deeper into the pictures and the work that Rod Warren and I have been doing together, him showing me in graphic pictures these particles. This is a muon neutrino, a gigantic deal to physicists. This is an electron neutrino, holy smokes. And they thought these were the only thing that existed until they found what they call a tau neutrino. These are the smallest particles that exist. And they, in my world, and I will show you, they hook together. And when they concuss, that one stays just a black ball, and this white ball turns into an explosive thing. Now, they call this Cherenkov radiation. And what it is this particle coming in is faster than the speed of light for the medium that it's going into. All right, so they use heavy water in the nuclear reactors, and they send these particles in, and they get concussed into this heavy water, and that's what keeps the particles from going out and killing people. What we're doing is we're accelerating the light through a venturi. So now, instead of having it come off a nuclear reactor with extremely violent speeds and chunks, because what they're doing is they're hitting chunks. We're using light. We started with light. It's red laser light, green laser light, blue laser light. And then we put it through a venturi, which accelerated it within this same medium. So as soon as it came out of the accelerator, it crashes. When it crashes, you get this from the electron, which is attached to this muon. In other words, this is the positive and this is the negative. The bar magnet. But when it has to go through this venturi, they separate. Now, I'm going to show you that. And I claim we have already shown these neutrinos. Now, the tau neutrino, well, I'll show you. I think it's something like 60 times bigger than the electron neutrino. Heavier, more massive. Literally weighs more, a bigger chunk of matter. To my mind, that's what they're saying. Or is it just hitting harder? There's no difference between something hitting harder or having a more mass, because mass is force. Force is generated by speed or the size of it. If it's a big thing rolls against it, you don't need much of an impact to do a lot of damage. If it's a little thing, it hits it bounces right off. So you need a lot of impact to do the damage. It's just very simple, basic. And we're going to see these bar magnets separate, and literally that's what light is a bar magnet, and they're back to back. They create photons, and they will look just like this. Hold on, here it is. They will look like this. There'll be a black and a white, and they'll be back to back, one this way and one that way. All right, so there'll be one up and one down. That means there's two electrons, two of these. Electrons always want to be incorporated with something else. They'll be incorporated with light. They're happy to do that. That works fine for them. And that will hit you and not kill you. Electrons are different. If there is enough of them in the potential, they will kill you because they will force their way through the matter that they're going into if there's not enough electrons to accept them. In copper wire, they force their way through, but there's tons of electrons, and zip, they go right through there. It's called conductivity. If there isn't enough electrons to accept them, and they want to be forced through with lightning or static or electricity, it will burn and sizzle and it will deconstruct the atoms that are in there, because these will force their way into their atomic structure. These don't. These bounce off. Light is a different issue. It's a multiple of electrons. Electrons want to hurt you. These want to warm you up and want to create life and do all the good things. It's two levels of energy. Now, that's what they're talking about, the muon neutrinos and these tau neutrinos and so forth. Now they're talking about a sterile neutrino, a fourth. We got some thinking to do. All right, my friends, I think I am as close to anybody as figuring out what the atomic nature of the nucleus is. Think of this. CERN is exploding gigantic chunks of things together. Boom, and then, which are nucleuses. For me, that's gigantic, because a helium to me has 7,350 electrons, because everything's made of electrons. And these, every black ball is attached to a white ball the same size. I call that an electron. When you put two of them back to back together, as I think I have shown you before, I call that a photon. Photons bounce off things, creating light. Electrons incorporate themselves into things, creating, if they're gently pushed in, they create heat. If they're extremely violently pushed in, they will electrocute you. They will force their way through the matter that's in front of them that may be restricting them. If it's a copper, they go right through, because there's a billion zillion extra electrons. And all of these are little electrons, and they'll just keep pushing ahead of them. So, and then your insulation is around the copper, so it doesn't bleed off into the air. It says, no, 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 you guys stay in there. I won't allow you to come through. And it says, no problem. They got enough electrons. I'll just keep going. And that's what happens. That's how wires work. Now, in the air, different story. In the air, it's always pushing back. Always pushing back, because you're hitting particles. Now, what they're doing with these deep earth electron neutrino things, there's no way they're going to go to, in my world, the black ball wants to be with a white ball. The black ball says, I don't explode. You can't make me explode. I'm not that kind of matter. I don't explode. Nothing you can do to make me explode. I'm just going to stay where I am. I'm a little black ball. I like being a black ball. I'm a little black ball for the rest of my life. Well, the white says, well, you come near me and we're going to have trouble. They said, well, just push me out of the way. I go, well, look, here I am. I'll just get out of your way. Don't worry, we'll come back together. We'll make friends. You push me away. I don't care. I can get along with you later. We'll get back together. And that's what happens. They get, but what about there? We got an area there that is in need of at least looking into. And we are. And I think this is literally electron showers. And these balls are literally electron shower neutrinos, electron neutrinos. Okay, so in other words, they're electrons, and they're the part of the electron that is the negative part, which is explosive. So these are electron neutrinos. Now the muon neutrinos are like the positive side of the electron, and it doesn't explode. It just rolls away, the black thing. I know I'm going to length about this, but people have a hard time understanding this. And I do too, because I find it very hard to understand how they could, why this is not the same energy as the white one. But we know it isn't, because it rolls right away, and it never explodes. It never seems to get upset about anything. These things here, that's what causes light. Now, depending upon the frequency that it's coming in, is what it interacts with, is the molecules that have particles in a certain range that will interact with these. That's why you get the green and the red and the blue. They're longer frequencies. And the red is the longest frequency, and it concusses right at the venturi, right here. The venturi is right here. I believe this is right here, the venturi. All right. These balls don't start to separate until they're right here, and they don't start to even show up as the black and whites together until they're right up here. Now, in the green, it happens way back here, because they're being concussed and emitting light at a higher output than the red is. And I can show you that. Rod Warren did the light experiments here. You know, we worked together for years doing this. I do the electronic theory. That's strictly my side of it. And, you know, and I use his work, and he does fabulous work, and he keeps feeding me with more information. Now, and I put out some word, as anybody else can do some stuff. And a guy named Fabien Boulet over in France sent this in. Hold on. And this will show the difference between the red and the green concussion. All right? Because he sent them through a venturi. I think maybe like the venturi was tall, like this tall, and he sent the red down here and the green up here, something like that. And it went through the venturi, and we can see, where did it concuss? The red is done concussing right about here. Well, the green didn't start even to concuss until it was way out here. So obviously it was much more energy. Let's take a look at that. All right. You have no idea how long I take sometimes looking at these things. Let's take a look at it. Let's think about this logically, what happens. I say the more particles you push in to a region, they want to invade other particles' regions. So you have a dot right in the center, which is the particle, and it owns a region like this. When another particle comes bashing into that region, you get glow. That's the only reason you ever get glow, is something is pushing on something else. So what do we have here? We have the red laser, we have the green laser. Actually, that's the red, and that's the green. Now, what is really going on here? The red is concussing upwards and making the green show a little more impact, because it's impacting with the red concussed particles that are surrounding the red laser, and the rest of the red laser is being pushed down below. So it's actually literally the green is pushing the red away. All right, think about it. Think about this logically. Now, look at the difference of the impact value between the red and the green. You see the blue and everything here? This blue means it's like even beyond the energy of red. So you see some blue. I hope you can see this. I don't even know if you can. Now, he's showing up here. Some reds got thrown, a couple of little reds got thrown up in here. You see them over here? And then he's showing that you can see the green particles. The green particles are starting to show up as they slow down. Now, normally I see the red particles showing up as they speed up. These are showing up as they're slowing down. Now look way out here. Here's the green really concussing. The only reason we're seeing this green concussing is because it's got to make its way through the concussion of the red. The red has made all of this into a different zone than this. All right, think about it that way. This fluffs this up like fluffy. So when this has to come through, it's interacting with these fluffy particles, which are only here, because the red is only up to here. And then once they get out of there, they keep going at their extreme speed, because they're much more energetic than, obviously. We could see all of this if you just take your time to sit and think. And then they concuss out here into what is normally the space of the air and that type of density. This has become extremely dense because it's being fluffed. And that's why they show up here. And I hope that made sense. But you can see they are the same black and white particles. They're up and down light. And again, if you separate that, I believe you have to separate them to make electrons. And if what happens is, the reason you get electrons flowing is you're going to have mass. And that mass, all right, let's take this. You're going to have a mass. Let's take that as a nucleus. And for me, they're all electrons. And then it's going to be in a soup of electrons, like in a bowl of soup of electrons, exactly what it is. So it controls, though, a certain number of electrons, and it sort of holds them kind of tight. Now, what will happen, though, is you can flood more electrons in. The more heat you put into something, it's just literally you're putting more electrons, and they're just sitting around in that soup, available to flow out of there into an area that wanted them, where it was cold, didn't have enough electrons. They go out, and they become stable, and you get an ambient temperature. Everybody's the same temperature. Now, if you force with an air gun, heat gun, fire, or anyway, breaking any molecular bonds, you release electrons. Those are nothing more than balls of energy. When those balls of energy are released, they push on everybody else. That causes glow, that causes heat. If you really push the hell out of them, and there's so many coming in, they can't, the soup boils, literally boils. You're going to break down the things that are in it, just like you break down the food that's in the soup. Your potatoes are going to mush out and everything else. So you're going to create new matter. It's as simple as that. The more electrons you force into the soup, the more changes you make to the particles that are in the soup, which is the vegetables, the meat, the potatoes. You know, it's just the way it works. There's no difference whatsoever, literally. I'm not kidding you. And when you turn on the heat to heat out your pot, you're just pushing electrons in. That's all you're doing. And then you say, "Oh, look at the little bubbles forming on the bottom." Of course they're forming because they're balls of... Let me show you what happens in space. Now, there's another one from Fabian. This time there's no red, and you can see the green just starts to concuss way out here. So it's a different impact. Now, is it because they're going faster? Is it because the frequency is longer? But he's got the same particles he's showing all over the place. Fabian, thank you, my friend. And as always, Rod, numero uno. Okay, this is about the tau neutrino and tau leptons, and I think I can show you these possibly. I'm just going to say maybe. Now, here's what he has to say. This is the director of he does something at CERN. I don't know exactly who he is, but he's one of the top guys apparently. And now here's what he has to say, and this is about looking for this tau neutrino, and they believe they found it. Now, apparently it's 60 times heavier than a regular neutrino, which I believe I have shown you, or I will show you. Watch this.
What we want to do with opera is to detect the appearance of the different flavor. So
okay, the opera is their device that is searching for these particles. And again, I keep doing this. Let me come back. So he's talking about opera and what they want to do, is what their mission is here.
opera is to detect the appearance of the different flavor. So we know that we start with mu neutrinos and we will get eventually some tau neutrinos. And we want to detect these tau neutrinos. When a tau neutrino does something in our detector, produces a tau lepton. And we detect this tau lepton. So this is the first event which is compatible with the detection, with the observation of a tau lepton.
All right, I think they draw a different conclusion than I do because they have seen a particle, but I think it's a reverse spinor particle, possibly. I'm just throwing this out because I see a particle I can't account for. I've seen both the normal electron neutrino and the muon neutrino. That I'm pretty solid behind. This tau neutrino could be the other particle that I saw, which is obviously much denser or more massive, more energetic than the other neutrinos. Now I'm going to show it to you. And they say, here, let's just go a little further. All right, I'm sure I've shown you well, I'll show it to you again because sometimes people forget. This is red laser light accelerated, creating a separation from the non-concussive, non-explosive black particle from the extremely explosive white particle. And here's the extremely explosive white particles. There's the non-concussive, just black particles that were originally attached, and they looked like this coming in. I'm sure I've shown this, or I'll probably show it again. And at this point, there's two black balls here, one here, and then they're, well, not black balls. They're this right here. They're tubes of steel, and they have to force their way through it. You can't see it's just so explosive. But there's like one black steel ball there, one steel. They're pins, steel pins. They're nails, actually. This is down at the size of light, so these are like steel nails. Now, but it's extremely explosive, and the black parts just walk away from the white. I think that's pretty obvious. Now, I think also that it seems to be pretty obvious that the Bohr model it's been proven wrong. And it appears that the nucleus is made of these same particles, these black and white particles. And when they are together in a nice stable configuration, they are exact quantities. Helium, in a base form of helium, is 7,350 electrons in this core. That's 2 hydrogens and 2 protons, 2 neutrons. And then it only has enough value to hold on to 2 other electrons that are surrounding it. It influences 2 electron entities. Let's go with that. But let's just go a little deeper with this, or maybe I'm ending it right now. I don't know. But I'm going to tell you what. That, in my world, if they're looking for a non-explosive particle, which is the muon neutrino, and then they're looking for electron shower neutrino, those are them. This is accelerated, no question whatsoever. That is exactly what they're talking about. Cherenkov radiation is accelerated particles in a medium that they're going faster than the other particles in this medium. It's just a basic. This is what it is. Just look. You can look up the stuff. It's not. There's no mysteries here. It just needs to be looked into. There's tremendous amount of changes just based on electron flood theory. And then when you can see that we can see the neutrinos, and now we can talk about the tau neutrino, because they say it's 60 times more powerful than the electron neutrino. And I believe these are powerful. Now, the other one looks to be extremely powerful, and I'll show you that. All right, I'm just going to sum it up. That's just light, the pulsed red laser. All right, approaching the venturi, that is what happens. The red laser pulls forward, the particle comes out. I've shown this, I think, pretty clearly. Now, the other thing you want to notice is you see all these reverse waves? That's from this impact coming backwards. They're supposed to be going this way, but this is sending extreme violent waves back. Huge interactions. This is those particles coming out of the venturi at us. This is extremely interesting because this has gained wavelength energy. It's crushed it down on both sides and turned blue. That's very strange because it started red. This is the particle, I believe, that is possibly this lepton, whatever the new one is, the tau neutrino. Where did they look for this neutrino? Did they look for it right here, or did they look one that's concussed? If they found it here, they would see this extreme energy compared to this energy. That is spinning, I believe, gathering its force. These are splaying the forces outwards. So to me, that's what I'm seeing. I could be totally wrong, but again, here's a crushed particle. There's some very strange interactions that are seen here using the venturi. And the beauty of the venturi is we can vary the width and the interaction, plus the materials. We can put coatings on them. We can make them bouncy. We can make them really hard when the light hits it. We can do all kinds of things. But that's outside of my realm for sure. If somebody funded Rod, he might want to do that. But he's just another human being that has to consume oxygen and put food in his stomach every day. So, but there's a lot to look at here. The people that should be looking at it, I'd love to just say, "Hey, look at it." That's what all my research. That's all I ever said. Here, take a look at it. Nobody ever said they would never return your calls because I don't know. I'm not even want to get into that. But that's what that is. Okay, you saw the red electron showers. The green is a little more reactive. You see a more white spray, very, very reactive. Now, we did see one of those reverse spinners, though, here. Now, again, I'm just guessing, but this I see as not the same as the other particles. This showed up out as it was coming out, I don't know whether this is creating these patterns. I have really no idea, to be perfectly honest with you, but I can see it's an extremely brilliant particle, and then it's losing its particle brilliance. Now, all of these are particles too. You see every one of these? You see a little black dot? You see that black dot, that black dot, that black dot? Every one of these is a particle as well. That one there, though, is a lot more powerful than these. But these are particles. All right? When we're into electrons, we're way down into the particle range. But some of them seem to have extreme amounts of energy compared to other ones. But you could see, anytime you see a black dot surrounded by white, it means that the weak force is inside the explosive force, because we are in an explosive condition now. All right, one last time. You saw how explosive looking those green ones. They were very, very energetic. These are the red, a lot less energetic. However, we still had one of those particles that looked very similar to that. Now, if the other one, we could see it because it spun 5 times in the space of what this would spin only once. That's why we're only seeing one of these. That's to my take. I could be wrong again. I have been many times before. But again, correct me if I am, and then we will talk. I love you all. God bless you.